What if I told you that the sine of 30 degrees and the cosine of 60 degrees are the exact same number? Not a coincidence, it's a pattern. And once you see it, you'll never look at trig the same way again. Today we're going from zero to dangerous in trigonometry. We'll build 6 ratios from one triangle, unlock 3 identities, compute exact values for 60 degrees, and discover the hidden symmetry between complementary angles. And all of it connects. All right, let's build our playground. Imagine a flat line, call it OA, stretching to the right. Now picture a second line, OP, pinned at O. Rotate it counterclockwise, sweep out some angle theta. Freeze it right there. Now drop a vertical line from P straight down to the ground, hitting point N. You've just constructed a right triangle, OPN. 3 sides. The slant from O to P, that's the hypotenuse, always the longest. The vertical drop, PN, the perpendicular. And the flat stretch, ON, the base. Now take those sides and make fractions. Sin²θ, perpendicular over hypotenuse. How tall the triangle is relative to its longest side. Cosine²θ, base over hypotenuse. How wide it is. Tangent²θ, perpendicular over base. The slope. How steep? Now the next 3 are just flips. Cosecant flips sine, hypotenuse over perpendicular. Secant flips cosine, hypotenuse over base. Cotangent flips tangent, base over perpendicular. 6 ratios, 3 reciprocal pairs, all from one triangle. 2 quick bonus ratios from older textbooks. Versed sine is 1 minus cosine theta. Coversed sine is 1 minus sine theta. You won't use them often, but they're part of the family. And here's the crucial thing. Every one of these ratios is just a number, not a length, not an angle. A pure ratio that stays the same no matter how big the triangle is. Now this is where it gets beautiful. Take the Pythagorean theorem. PM squared plus OM squared equals OP squared. Divide everything by OP squared. PM over OP is sine. OM over OP is cosine. So you get sine squared theta plus cosine squared theta equals 1. That's the first Pythagorean identity, the most important equation in trig. But we're not done. Divide the original equation by OM squared. PM over OM is tangent. OP over OM is secant. You get 1 plus tan squared equals sec squared. And finally, divide by PM squared. OM over PM is cotangent. OP over PM is cosecant. 1 plus cot squared equals cosec squared. 3 identities, 1 theorem, 3 divisions. Elegant. Now, can sine theta be 10? Can cosine be 50? Think geometrically. The perpendicular PM can never be longer than the hypotenuse OP. So sine, PM over OP, can never exceed 1. Same for cosine. Both are trapped between -1 and 1. And since cosecant and secant are their reciprocals, flip a number at most 1, you get something at least 1. So cosecant and secant must be at least 1 in magnitude. Tangent and cotangent, though, no restrictions. They roam free across all real numbers. Let's compute exact trig ratios for 60 degrees. No calculator. Start with a line OP of length 2a, making a 60-degree angle. Drop the perpendicular PM. Now here's the clever trick. Take a point N on the other side of M so that MN equals OM. Triangle OPN now has all sides equal. It's equilateral. So OP equals PN equals ON. Since OP is 2A and ON is twice OM, that means OM equals A. Now Pythagoras. PM squared equals 4A squared minus A squared, 3A squared. PM equals a root 3. Now read off the ratios. Sine 60, a root 3 over 2A, root 3 over 2. Cosine 60, A over 2A, 1/2. Tangent 60, a root 3 over A, root 3. Clean exact values, no decimals. Now the beautiful connection. Two angles are complementary when they add up to 90 degrees. 30 and 60. Theta and 90 minus theta. The rule: the sine of any angle equals the cosine of its complement. That's literally why it's called cosine. The co means complement. Same pattern for the rest. Tangent of 90 minus theta equals cotangent theta. Cotangent complements tangent. Cosecant of 90 minus theta equals secant theta, and vice versa. 6 equations, one beautiful mirror symmetry. Let's verify. We showed sine 60 equals root 3 over 2. What's cosine 30? Since 30 and 60 add to 90, cosine 30 equals sine 60, root 3 over 2. Same number! Every time you compute one value, you get its complement free. Let's bring it all together. From one right triangle, we built 6 ratios, 3 primary, 3 reciprocal. We derived 3 Pythagorean identities by dividing one equation 3 ways. We discovered sine and cosine are bounded between -1 and 1. We computed exact values for 60 degrees using a clever equilateral triangle trick. And we saw how complementary angles mirror every ratio. 1 triangle, 6 ratios, 3 identities, 2 angles, 1 elegant rule. That's the foundation of all of trigonometry. If this clicked, hit subscribe and turn on notifications. Next video, we'll build the complete special angles table for 30, 45, and 60 degrees. Drop a comment. Did the complementary angle pattern surprise you? See you in the next one!